Hello and welcome to Almini Wilson, doing maths with you today. We are tackling October-November 2020 paper 12 together. I will be going through the full paper in this video. I would love to share with you what I'm looking at on my screen. We are doing October-November, like I said. And what you should have with you, what will help a lot, if you have the right calculator, if you have the FX991 ZA+, have your Cambridge formula sheet closed, piece of paper, ruler, hopefully your brain also work up and is ready to do this paper. Let me just show you what I'm looking at. I'm looking at this, October-November 2020, paper 12. Okay, an hour, 15 minutes, that's your allocated time. We might do it in less than that unless I get sidetracked. Let's start. Question 1. The coefficient of x cubed in this expansion is 20. Find the value of k. So let's write down everything we need from there. So this question 1. 1 plus kx, no exponent. Just notice there's no exponent. Then 1 minus 2x to the power 5. That has an exponent. That's probably going to use binomial expansion. And then they say that the coefficient of x cubed is 20. Okay, so let me show you what I'm busy with here on the side. I'm going to expand my one bracket. This bracket is the one that needs to be expanded. So when you do that, you can, just to set up the binomial expansion, you can do a few of these. It always starts like this, by the way, 5 0, 5 1, 5 2, 5 3, 5 4, up to 5 5, but you don't have to write all of them down. Then you do your first bracket. He will go down in powers. You'll notice he will go down in powers, whereas the other one, you can obviously go to the end, but you don't have to do all of them. The other one, just notice your second bracket. The first one will actually be to the power 0, so you don't have to write that one down. The second one, he will go up in powers, like this. So you can write down a few of them, but like I said, you don't have to expand all of them. Oh, sorry, this one must be 4. Okay, so then what happens is, I can also just show you another trick. This power will match with this one. This one minus that one will match there. 5 minus 2, 5 minus 3, and so forth. Obviously, this power will then affect your second bracket. This power will affect your second bracket. So what I'm doing essentially is I'm expanding this bracket without actually having to times it out. Okay, that's fantastic. We are going to focus on the things that will produce x to the power 3, because they were mentioning something about x to the power 3. Let me just check the question again. They did say coefficient of x cubed is 20. So remember, whatever we're expanding here will form part of this bracket. Then we still have to times this bracket with this bracket by selective multiplication. So I'm thinking, like I'm looking for things that might have squares in, because a square times an x will give me cubed. Or I'm looking with something with like a cube in that will times with a 1 to produce a cube. So what I will be focusing on is only expanding these two, because otherwise I'm wasting time. Let me help you a little bit with my calculator. What to press on your calculator when you want to type in this 5 2. There's a little bit of a shortcut. You just go 5. Let me just switch it on. 5, and then you want to get to this button, so you go shift divide. 5 2 is 2. It gives me 10. Fantastic. There's also a long way to do it on the formula sheet that you can have a look at if you want. Remember, if you have negative in a bracket with an even power, it will become positive. Yes. Oops, you can't see. So yeah, just notice how I've made this negative, I made it a positive. Also the next one, you type into your calculator, just to remind you, 5 shift divide 3, and then I get 10 again. This is all based on the Pascal triangle, that's why you might have doubles. 1 squared, you could work that out. I could have worked it out now. And then negative, it will stay negative. Like that. I think those are the only ones I'm going to expand from my binomial expansion. Please remember that is for the second bracket only. So the first bracket hasn't changed. You have 1 plus kx. Second bracket, let's just work this out. 10 times 1 times 4. 40x squared. Then we move on. This minus 80x cubed. All right. And then I'm not going to, there will be many others. If you want, you can put like dot, 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 because there are many other things in this bracket, but I'm only writing down what I need. There's this term, this term, this term that could have been in here, but I don't use it. Okay, so selective multiplication tells me I want a cube, so this will work. And I want a cube, so this will work. Remember, there are many other things that you can times, but we're not wasting time. We only have 4 minutes for this question, 4 marks, 4 minutes roundabout. So I'm just writing down what I'm getting here, 40k x cubed minus 80x cubed. We know that together, if you just focus on the coefficients, this will be your coefficient, and you can equate that to the original thing that they said at the top. They said my coefficient of x cubed is 20. So my coefficients of x cubed here must equal 20. And then it will be quite easy because I can just bring that over. It's 100. Ooh, why am I getting a fraction? It's okay. Let's just see 100 divided by 40. I get 5/2. Let's confirm, because I always feel a little strange if I get fraction. So that was my question. Let me just get to the memo. The memo says I'm right. Yes, that's a good feeling. 4 marks, done and dusted. Yes. Okay, it's always nice to get the first question right, then we can work from that momentum. Obviously, when you're doing papers, you shouldn't check the memo as often as I do, by the way. It's just nice to see on the right track. Number 2, also watching the clock. Hey, we need to do this in under hour 50 minutes, maybe hour 30 minutes, because then we can check still. The first, second, and third terms of a geometric progression. That means there's a constant ratio. 2p plus 6 minus 2p. So these are our first 3 terms. I'll just copy correctly, p plus 2. So those are my first 3 terms respectively, where p is positive. So that might mean that somewhere there's going to be an option and we need to choose the positive. Find the sum to infinity of this progression. Yeah, we can do that. That's all they give us. Okay, I'm just checking. Okay, so we're back to this. I've got my 3 terms here. I just want to remind you that it is geometric. So we need an R. Now R has a little formula, term 2 over term 1. And that's the same as term 3 over term 2. So if you want, we can quickly just work out what this will be. Term 2 over term 1 must equal term 3 over term 2. That is basically, if you do this, you will get the constant ratio. Now, I just want to quickly see if the mark allocation here, if they do want me to solve for P. Yeah, I mean, if it's worth it. I did say it was, how many marks? 5 marks. Okay, so I'm going to quickly solve for P. Just quickly check there. If you have a fraction, a single fraction and a single fraction on both sides of the equal sign, you can cross multiply if you want. So this is going to be 4p squared. Here, just be careful, you'll have to FOIL. So first times first, outer, so that's plus 4p, inner, just checking if I'm spelling FOIL correctly, huh? And then last. That's how you times out brackets. But you can't see. Okay, that's fine. It looks like a trinomial to me. So what I'm going to do is I'm going to bring everything to one side. 2p squared plus 10p. Don't make a sign error. Minus 10p. I'm bringing things over, right? Minus 12 equals 0. Then you can divide everything by 2 just to make it easier. And then if you don't have a smart calculator, obviously factors of -6 to get to -5. But I do have a smart calculator. Have a look at how I do this. This is a bit more intense calculator work. You can only do it, by the way, with the FX. Let me just show you. The FX 991 ZA plus. You go mode, then you choose equation. Then you choose number 3, the one that looks like an actual trinomial. And then only the coefficients go in here. So if I look at mine, coefficient is 1, -5, -6. So this is how you punch it in. You go 1 equals, -5 equals, -6 equals. And then what the calculator will give you at the end is actually the first X answer, which is 6. so that I know my P will be equal to 6. And I know my other P, if you press equals again, check then it shows you x2, will give me -1. But I do want to still get all my method marks. So make sure, bracket, 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 P minus 6, P plus 1 was not. Oh, and this is why they said positive P value. So we choose P is equal to 6. Okay, but we're not done yet. I'm going to just find some space here on the side. If P is equal to 6, let us just quickly go back to the question. And also I wanted to check if I'm right. P is equal to 6. Find the sum to infinity of this progression. So if we need to find the sum to infinity, this is on your formula sheet. Sum to infinity equals A over 1 minus R. To remind you, A is first term, R is constant ratio. So if I use this P being 6 into my first term, which is, T1, then I have 2 times 6 is 12 plus 6 is 18 over, and then you can use any one of these two R's. You could put it in here, minus 2, I'm just going to type that in, minus 2 times 6 divided by or over 2 times 6 plus 6. I get -1/3. That's great. Also, I wanted to confirm with you something. If you are going to infinity, your R needs to converge, which means your R needs to be a fraction. So this is actually a perfect scenario. So then you just punch that into your calculator once again. 18 over 1 plus 1 over 3. And then I get 27 over 2. And that is 27 over 2. I think I might have messed up this last part. Maybe it was with my R. Yeah, I don't think I put the negative in, to be honest. So if I put a negative in there, I get -27 over 2. And then made a little bit of a sign error there when typing in. This must be -2 over 3. And then when you type in the whole thing, you get 18 over 1 plus 2 over 3. So I get 54 over 5, which is my exact value, or you can say 10,8. That is what I wanted. Nice. Okay, that was quite good. We just need to have a look at the next question. 2 down, and I think about 10 to go. So this is where you take deep breaths if this was in your exam. Let's do question 3 now. Let's move along with this. Question 3 is for 5 marks. So I just want us to read this together. It has to do with points of intersection. And I have to tell you that I do see this quite often in past papers. You have to know what it means to find point of intersection. Okay, so have a look. The equation of the curve. So they give you a curve, y is equal to 2x squared plus m 2x plus 1. That's your curve. And then we also have our straight line. Okay, so they talk about the equation of the line and the curve. Show that for all values of m, the line intersects the curve at 2 distinct points. Okay, so I'm hearing some important things here. Show that is my first thing that I'm hearing. Show that. So we're supposed to not use the fact that they intersect at 2 distinct points. We're supposed to prove it. And they all are talking about intersecting. So we are going to set them equal to each other and 2 distinct points. Okay, let's do this. So the first thing I'm noticing is the fact that they said the word intersect. So when we intersect 2 lines and we observe how they intersect, we first need to set them equal to each other. If you've done this, you already get a method mark because you're setting them equal to each other. Then we bring everything over to one side. You can distribute this in to mx, remember times with both, plus m minus 6x minus 4. All right, so that is descending power, oh, not completely descending powers of x yet. Just have a look with me. I think a good idea at this stage would be to go 2x squared to mx. Look at how I write the x's together and then the constants at the end because they don't contain any x's. So this is how you observe points of intersection. I just want to remind you that when you do observe, so in other words, do nature of roots, there are 3 scenarios. This is where they intersect at 2 distinct points. It's where your discriminant or your delta is bigger than 0. There's also an option where it only intersects once, almost like a tangent, it is a tangent, where your delta or your discriminant is equal to 0. This you must study actually off by heart. And then there's another scenario where your line and your curve just doesn't intersect. So then your discriminant will be smaller than 0. And the whole time when I talk about discriminant, I am actually referring to a part of your quadratic formula, the part that actually is underneath the square root. And this helps you to solve any x value or x root. But you can just look at this for nature of roots as well, and then look at the 3 scenarios. Okay. Also, just to remind you, let me bring in some color here. Your A is x squared. Your B is, well, coefficient of x squared. The B will be the coefficient of x, which might be more than one term. Hey? And then your C will be your constant, or the value that actually does not contain an x. It can contain other variables, but it must just not contain an x. That's why it was clever to write it in descending powers of x. Now let's do this. Let's do the discriminant. So the discriminant is b squared. So this is my b squared. Notice no x's here. Minus 4ac. And we're supposed to show that or prove that this is the case, so bigger than 0. Fine. Then I want to show you when we do timesing out of brackets and you are unsure of how to do that, please just don't square the first and square the last. That would be terrible if you think, oh, square u and square u. That's not good enough. Rather write out 2 brackets if you're unsure. And then FOIL, okay? First, inner, outer, last. Almost got sidetracked there. But if you want a shortcut, I know many people want shortcuts. Let me show you how to times out a square bracket. You go first, square the first, so that will be 2m squared. Square the last, but don't stop there. And then go first times last times 2. So I'm going to go 2m times negative 6 is negative 12, so negative 24m. That's how I FOIL that out. Then this is going to become negative 8, and I'm going to distribute that in here. So that's going to be negative 8m plus 32. Okay. When I get to this stage, it looks like a trinomial again, but please, no x's here. Only coefficients of x. I didn't want any x's because otherwise you have too many variables. Okay, then let us quickly see if we can try and prove that this will be positive. I'm going to do this because that is my descending powers of m this time. If you want to show that this, because remember in the back of your mind, you must keep thinking about this bigger than 0. We're trying to prove that this will always be positive. So if we're trying to prove that this is always positive, let us quickly have a look at maybe completing the square. Now, completing the square puts this equation into this form. And once you do that, you basically prove that it will always be positive because a square bracket is always positive. Okay, so let me show you how to do completing the square. My first step will always be common factor. So you take out a common factor of 4, and you go m squared minus 8m plus, ooh, I need to know that, 68 divided by 4, 17. Okay, so the golden rule is common factor first. And then I would love to see you take your coefficient of x, or in this case, coefficient of m. I normally do like a little side step here, just to remember, I always go half times coefficient of x squared. This is a recipe, like this will never change. Then you square that and you get an answer of 16. So what I do at this stage then is I use this side step right after my m. So I'm going to add 16 and minus 16 because you can't change the value here. When you add something, you need to subtract it again, plus 17. Okay, so far, I've only used the last step. So you use the last step, add and subtract, always add first. And then you have minus 8m plus 16. You can work out what this gives you. This will be plus 1. I'm actually wasting a step because you can already in this step take your first 3 terms and put them in a bracket for me that is squared. This is called completing the square, right? And when you do that, you can say that this negative 4 will be inside. So this is m minus 4. Okay, and then what you can do is you can complete the square here. So what is left over this plus 1. But please remember that this is still in a bracket. So you have 4m minus 4 squared plus 4. What this basically means is this will never be negative, because if you put any m value in here, it will be positive because you're squaring it. And then you also add 4. So, I mean, there's no way that it can ever be any of the other scenarios. It can never be this one, because it can never be 0, you're always adding 4. And it can never be less than 0 because square numbers are always bigger than 0. So I'm getting into a lot of nitty-gritties here, but this is basically what it boils down to. If you want shortcuts, guys, I know you like shortcuts. Mode 5.3, my favorite mode in the world. You still just go mode equation 3. And then I would type in, which step? I can even start typing that step. 4 negative 32, 68. 4 negative 32, 68. And when you type it in, okay, I know you're getting imaginary answers there, but this is important. My x value minimum, I know it says minus 4 here, but if you read it off, so your minimum value will be 4, and your other value is also 4. Okay, so we've got the turning point basically then, and that also helps you if there was a different question for completing the square. Okay, I'm happy to move on with you. The next question will be question 4. Just want to make sure for mark allocation for question 3, if everything is fine there. So yeah, you're setting equal to each other. You use b squared minus 4ac. You get your minimum point, and then you prove that it will always be positive. Yeah, I think you can check the memo yourself. We did everything that we should have done. That was question 3. Now question 4. Remember to take deep breaths in between. Let's give our brain some oxygen. The sum Sn of the first n terms of an arithmetic progression. So they give us Sn. Nice. Plus 4n. So this gives us the sum of all terms is equal to the n will be the number of terms squared plus 4n. The kth term, so I'm just going to say tk, the kth term is greater than 200. So I want to know when is the kth term greater than 200. Find the smallest possible value of k. All right, let's try this. First thing I'm noticing, they give me Sn, but then they keep asking me things about Tn or Tk. So I want to remind you that sum of tells you like term 1 plus term 2 plus term 3. So we have a little bit of a problem if I want to use this formula. If I get the sum of the first 1 terms, this is how you do it, by the way. Sum of the first 1 term is technically the same as the first term. If you're with me, like I'm only taking term 1 and adding it to himself. So what's nice is you can remember that term 1 and S1 will be the same. So let me work this out. This is 5. Then if I do want to work out sum of 2, you can just pop a 2 in, see what you get. Let's see how good your mental maths is there. That is 4 plus 8 is 12. But now this 12 is not term 2. This is actually term 1 plus term 2. if you think about it like that, because sum of 2 means you added 2 terms together. So now if you want, here's a nice formula that you can remember. You can say term 2 will equal sum of 2 minus sum of 1. Let's see if that works out. So my term 2, if I wanted that, I can go sum of 2, which was 12, minus sum of 1, which is 5. Okay. I'm happy with that one. But then also, if you want a formula, you can go Tn is equal to Sn minus Sn minus 1. Whichever formula you prefer. I just wanted to make sure that you don't think that this is term 1 and this is term 2. So far, what I've got for you is I've got 5 as term 1 and 7 as term 2. Let me just quickly confirm that they tell me that this is arithmetic or geometric. They said arithmetic. Yes, I don't need to get a third term. I think these 2 terms are good enough, because then I just want to remind you, if it's arithmetic, there will be a constant difference. So I want to know about the constant difference here. I did add 2. If you want a formula, term 2 minus term 1, that is basically D. Or term 3 minus term 2. Also, my first term is 5. And then if you want the kth term, I can give you a formula. We normally call this Tn. And I think on the formula sheet, it's like something like Un. But have a look if you can find it on your formula sheet. This is the one that I want for term 1, term 2, term value for arithmetic. Okay, they want to know, what was the question again? I'm just subbing everything in. 5 plus 2n minus 2. I know this is a bit tedious. Okay, that's fine. They wanted to know which term starts being bigger than 200. Okay, we can work that out. Bring this over 197. Don't make sign errors. I'm getting 197 divided by 2. That is 98,5. Which means that, remember, n has to be an integer, because n refers to term 1, term 2, term 3, term 4. We don't, if we're looking at a sequence like this, we don't go term -1. We don't go term 2.5. It has to be a natural number. That's something that you must remember. So if they do ask you something about this 98.5, it has to be bigger than 98.5. So you can't choose 98 as an integer. I would love for you to make a statement and then say n is 99. Let's see if that works. Let us do some trig now. Question 6. So for trig, which is my favorite, I have to admit, I feel safe with trig. We have got a bracket on the left-hand side. Please notice they say prove that or sometimes show that, which means I do want you to keep them separate if you don't mind. Don't bring things over. I'm already changing the things that I can see, like I changed my tan x into sine over cos. So what I mean is separate them when you copy down or in your first step already. Have a left-hand side and a right-hand side very clearly, like this. Left-hand side, right-hand side. So my left-hand side, you'll notice I'm already doing this. You can even do it to this tan if you want to change him into sine over cos, but it's 1 over sine over cos. So then just flip your fraction like that. Then I've got on the left-hand side a little bit of a FOIL situation, but maybe you can make your life easier by just noticing that these are both over cos x. And then I've got my second bracket. And then I'm just going to distribute this hectic fraction in here and in there. What I will do is I'll go top times top. If you're timesing fractions, you do that. Top times top and bottom times bottom. And then times it there. And then what I'm seeing is maybe for these two terms, we can do an LCD. So what I mean with an LCD, we put them both lowest common denominator. we put them both over sin x cos x. So what you need to do is you need to check, what do you need from the LCD? Nothing. What do you need from the LCD? You need a sin x. Check, we are only considering denominator versus denominator. And then let's clean up the top a little bit. Plus sin x minus sin squared x. And then let's see how much we can still do. They said these can cancel. Okay, no, they didn't say, I said. They said we should try and get, just throw your eye over the right-hand side, a cos over sine. So what I'm seeing, I've got at leftovers 1 minus sine squared. 1 minus sine squared becomes cos squared. And then cancel, cancel. Oh, lovely. Cos x over sine x. Done. That actually went quite easy. I don't know if that's the correct English. But we've got left-hand side equaling right-hand side. Hence, yes. After this one, we've got a hence, which basically means you have to use the answer from before. So hence is spotting similarity, but also spotting differences. I'm seeing this being repeated there. So just notice this whole piece there can just be replaced with 1 over tan. Okay, so when you copy this down, I'm already just going to say 1 over tan, which replaces the whole of this left-hand side, must equal, and now it's not proving, this is solving, tan squared x. Okay, so have a look at what I did. I hinged correctly, which is also probably not correct English, but I did sub in what I proved just before. And when I try and solve an equation, because this is a proper equation, I can times my fraction to the one side. And then I'm going to try and solve this. So this is going to be a half tan cubed x. To get rid of a cube, you can cube root. On the calculator, if you're unsure where these buttons are, let me just show you where I'm working at. You can use this button, shift this one, because it gives you the cubic. Or if you want an open one, you can just use this button, this one, because it gives you an option to put whatever you want into that space for cube root. Okay, by the way, cube root of 1 over 2, I don't think it's going to be pretty. It's going to be 0.79, or you can keep it like this in this form if you want exact value without rounding off too much. So I've got at this stage tan x equals, I think I'm going to keep it like this for now because I get like 0.793. Not too tidy. I don't like irrational numbers. If you want to get x though, the angle x, you'll have to technically divide by tan. But we don't say divide by tan. We actually, the fancy name is called arctan. We arctan this side. So what I'm going to do on the calculator, just make sure that you are in degrees. That means it needs to be a little d at the top. What I mean with a d at the top, there. Just check that you have a d and not an r on your calculator. We press shift tan. So shift tan or arctan of answer. If that makes sense, let me just show you how I type that in. You press shift tan and then this button at the bottom here that says answer. And then we get a reference angle. Now that 38.43 is going to be my reference angle. Please remember that if you are working with tan, there are certain rules that you have to remember. When you write down your reference angle, there are other angles that are going to work for tan if you think of the tan graph. So I'm going to say here plus K180 because this will create a method for me. If you can remember that K must be an element of integers, you can sub in any value into K and still get answers that work for this specific question. So what I'm looking for now is an interval. Okay, so they've got an interval 0 to 180. So I feel like I don't have to add the K180. You'll see if the interval is larger, you might have to add 180. If I look at my answer 38.4, yes, they do say if you want angles in degrees, you round off to 1 decimal. Okay, then we're moving on to 7. Wow. I do feel like that was a hectic trick question. We had to prove something and then use it in the next question. Let's move on to 7. Next question. The point 4 and 7 lies on this curve, but you'll notice this curve has already been derived. So that's why the apostrophe is there. It means it's already the derivative that we are working with. And they say a point moves along a curve in such a way that the x-coordinate is increasing at a constant rate. So if I hear rate, I want you to think time. So if I say dx, so how my x is changing over time, I'll say dt is 0,12. I know sometimes the wording confuses us, but if you have a method like rate is time, it becomes easier. Find the rate at which y is increasing. So I'm looking for dy dt, unknown, and they do tell me x is 4. Okay, let's just see, I did go from English into calculus. I have my rate of change of x. I want my rate of change of y. I've got my derivative. If you don't like the way I wrote this, you can call it dy over dx. That's also another way to write derivative. So that is this. But by the way, I've got a 4. So pop the 4 into the x. Let's see what happens. Because I am then able to easily get an answer for dy dx. You will see later it will become important that I have an answer for this one. I'm just typing everything into my calculator. Bracket usage, super important to type it in exactly as is. And that's why this display is actually excellent for the Casio. If you do want to see how I typed it in, let me just show you. Exactly as is, right? Check. The way that they wrote it with brackets, negative exponents, all of that, you type it in, and I get an answer 5/2. Okay, fantastic, 5/2. How do we relate all these variables though? There is a formula sheet on your formula sheet, page 2 at the bottom. You will find the chain rule. So the chain rule is this: dy over dx is dy over dt divided by dx over dt. You'll see everything matches if you look at the dy and the dy. Even if you flip this one, the dt and the dt will cancel. So this chain rule is very useful if you want to relate 3 variables with each other, like time and x and y, like in rate questions. So this is just from the formula sheet. You also see the left-hand side doesn't have any t's in it. If you do get confused where to put what, let's sub in what we have. We've got dy dx. We have got dy dt. No, this is what we're trying to find. And we were given dx dt. Now it becomes super easy because if you want dy dt, you just take your answer that you just got times by 0,12, because that will give you dy dt on its own. So what I'm seeing here, I'm getting, yeah, I got 3/10 from my calculator. So when you want dy over dt, you say 5/2 times by 0,12, and then just give it to me in fraction decimal, I don't mind. 3/10, yes. I am moving on with this one. I'm going to B. Just remember, we are still working with the original curve that they gave us in the beginning. They said, I'm just going to copy this down again. The derivative was 6x to the power negative a half minus 4x to the power negative 3/2. They give us a point on the curve. Okay, so let me just show you what I've got. For B, I just copied down the derivative again. So that's my derivative. If I want my actual curve, I can take this and just say f of x, and then I'm going to do something called integration, which is basically antiderivative, which means whatever you did when you were deriving, we're going to undo it. The formula sheet also tells you how to do that. you add 1 to your exponent and then divide. And here you do the same. Add 1 to your exponent, you can use your calculator if you're unsure, and divide. And then remember to say at the end here plus C, because when we derive, normally my constant falls away. So there might have been a constant that I didn't know about, and now in my integrated form, I'm just allowing for a C value. And this 4 and this 7 suddenly becomes very useful, because in this first step, you were not allowed to sub in the Y, because this was not Y, this was M, this is gradient. So in this integrated form, if you look at the original curve, you can sub in your Y value. You can maybe clean this up a little bit before you sub in. What is 6 divided by a half? Type it into a calculator. That's 12. Sub in your 4. Just take the double negative there. Divided by a half is 8. And then you can work out your C value. I don't think that that's too difficult. Type it in, type it in, type it in. And then we'll see what our C value was. -21. Do you see if you'll get your marks for integrating nicely, subbing in? So my C value, by the way, was equal to -21. I hope you got it. You can pause this video if you want to quickly work it out. Let's move on. Let's go to 8. Yes. Circular measurement. You have to keep yourself motivated. You hear me saying yes for every new question. Okay. Deep breath again. Let's do 8. In the diagram, ABC is an isosceles triangle. Isosceles, 2 equal sides, equilateral, all sides equal, scalene, none of them equal. Isosceles triangle with AB equaling to BC, so they are both R. They also say angle BAC is theta. The point D lies on AC. Okay, there's D. And ABD. ABD is a sector of a circle with center A. Ooh, what? That means that if this is a sector of another circle, that means that this whole side, this AD, is also R, because AB and AD will be radii, and they have to be equal. Express the area of the shaded region, okay, in terms of R and theta. Okay, so what I'm seeing at the moment is I'm seeing a lot of different components here. I'm seeing a triangle. I'm seeing a sector. So I just want to remind you at this stage to have a plan. If you want area of shaded, I don't know how you want to write it, area shaded. I want to say, maybe just suggesting a plan, the triangle. No, I just need to get the name of that triangle. How about a triangle ABC? And I want to minus then sector ABD. Sector ABD. Remember, sector goes to the center. If you had a segment, you won't go to the center. Okay. So I've got formulas for you. I know I don't have a 90, unfortunately. So for triangle ABC, I'd rather have you using this general formula, half AB sine C, which you might have learned in IGCSE. You need a side and an interior angle for this to work. And sector area is just half R squared times theta. But just remember, your theta needs to be in radians, otherwise this doesn't work. Okay, let's tackle the triangle first. So I would love to use, if I had to use this triangle, I would love to use angle, side, interior angle. Because you can't really use this angle. I know it would have been perfect because you don't have this side. And the way that the formula is structured is side, interior angle. I'm going to make a suggestion. We need to find this angle. So if I know angles opposite equal sides, this theta will also feature there, theta. But with Cambridge, you don't have to give me a reason, but the reason is angles opposite equal sides. And then angle B will be, I'm just going to make a statement here, angle B is going to be 180 degrees, or you can say pi minus 2 theta. You see, that's already going to help me a lot. Because then have a look at how I'm going to implement this. I know that this is just a general formula, but what this means is side, side, interior angle. So what I'm going to do is I'm going to say side was R, interior angle is then this guy. And then I'm going to use my other sector. This sector is going to be quite strange because my sector radius is radius and my sector angle is theta. So that's all I need there. I'm sure you can keep it there. I know we can reduce, can sometimes reduce the angle a little bit. Let's see how far they wanted us to go. Yeah, a little bit further. Let me show you what I'm looking at. They are saying we must take our half r squared sine. That was for the triangle. Yes, we got the same. I didn't really mind if we wanted to simplify this. You could have just kept it like this and then subtracted the 2. If you look on the memo, they did go in one of the options, they did say that sine 2 theta is the same as 180 minus 2 theta. That is if you know the cast diagram well. The cast diagram starting here, 180 minus 180 plus. But if that wasn't part of some another lecture, then don't worry. And that is what we wanted for the area of the shaded region. Okay, everyone still with me? I want to see, we might have to do a follow-up question for this. Let's have a look at the next one. 8a, we did express in terms of r and theta. Yes. In the case where r is 10 and theta is 0.6, let me just write that down. In the case where r is 10 and theta is 0.6, find the perimeter of the shaded region. Perimeter of shaded region. Okay, so I already have BC. Okay, great. That's just 10. I would love to know this little section there. So let me just make a plan here. I'm going to say perimeter will equal basically BC plus DC plus arc BD. Yes, that is my plan. If I want to write down what BC equals, BC is equal to 10. DC is going to be a bit of a problem. We'll speak about that just now. And arc BD, I want to remind you on your formula sheet, there's a formula for arc length. It's just r theta. So r in this case will be 10 and theta in this case will be, I did write it down, 0.6, come on, 0.6. So far my plan is going pretty well, except I don't know how to get DC yet. There are plans in place, formulas in place for if you don't have a 90. And one of the other formulas will be maybe cos rule to work out this whole side, AC. We can use the cos rule. Now this should have been taught in IGCSE, but if you didn't remember, I can help you now. The cos rule, the basic one, looks like this. It's not on your formula sheet. If you want it, you have to memorize it. It works like this. It's basically the same as the area rule, where you have to have a side and an interior angle. And you'll also notice that this relationship with this will be my side and this will be my angle, but they will be opposite each other. So keeping that rule in mind and maybe quickly copying it down, I've got side 10, interior angle, remember that weird one with pi minus 2 theta. And then I also have my AC, which is the one that I want to work out. So this is a perfect scenario to use the cos rule. Basically, this is the AC I'm looking for. This is my radius, or just R, like they gave it to us. And my interior angle was B. So I'm going to write it down like this. Okay, you can't see. That is what I want the cos rule to look like. If you then go further and work out a few of these, just remember you have theta. This must be 0.6. So just type it into your calculator for me. 10 squared plus 10 squared minus 2 times 10 times 10. Don't press arc cos, you press normal cos, but also I'm like mid-sum already, but I want to show you something. If you want to be in radians, pi is a dead giveaway that you have to be in radians. At the moment, there's a small d here. I want to show you how to change it into radians. Shift setup, go to 4. Now you'll see, you'll see that there's a small little r at the top. So now my calculator will be able to handle what I'm typing in now. Cos pi, shift there, that's pi, minus 2 times 0, 6. Okay. I get 272. Just remember, this is now AC squared. Whatever you get for an answer now, that'll be AC squared. So then just square root that answer to get proper AC. Let's see if we are matching with them here. Yeah, I got for AC, remember this is not the true side that we were looking for. I get 16,507. That's what I get. So I just want to go back to the plan. The plan was BC plus DC. Remember, this is not DC yet. We have to minus AD, which I told you in the beginning was 10. So if I minus AD from AC, I get 6,506. And then if you add them all together, you should get to 22.5. Yes, 3 significant figures. 3 significant figures. Wow. Okay. Is that all you have to offer for me for sector measurement? Yes, it is all. This is part of the new syllabus, by the way. Question 9 is circles. So the basic thing you need to know from a circle, unfortunately, this is not given to you, is the formula for a circle. But let me just first write down for question 9 what we were given. B is 5 and 1. A is -1 and -2. And the B is the center and A just lies on the line. Then they want the equation of the circle. So just to make sure, have a little picture. This is B. A you can put anywhere. It doesn't have to be on a Cartesian plan. Doesn't have to be correct. But just have this in mind in case they ask us questions later. Also something to notice is a formula that's not on your formula sheet is this formula that represents a circle. A and B will be your center and R will be your radius. I'm just checking, maybe I'm doing this wrong. Now B is your center and A is your point somewhere on the curve. Okay. What I would love to do first of all is sub in my center. So when I sub in my center, I do it into small a and small b. And then I would love to sub in my coordinate that lies on the circle. That you do into x and into y. And that will give you r squared. So you can literally just type that in. Just don't forget these little squares. Type that in, see what you get. I'm hoping that you will get a very nice r squared of 45. Yeah. And then you just write it down as one equation. Let me just show you. If you once you've gotten your answer of 45, just write down your center. Keep your x as an open variable for now. Write down x. Write down y. The center's there, and then just put in there, oh, short-term memory loss like a goldfish. What was it? 45, sorry, 45 was r squared. Just remember, I'm not really interested in what r was. I'm interested in r squared. So I'm just subbing that in for now. Okay. You'll get all your marks, by the way. This will be 3 marks for basically doing the distance formula. Next question, a bit more difficult. Point C is such that AC is the diameter of a circle. Okay, so point C is, I'm just going to place it somewhere on my sketch. So point C is just randomly there, so that AC is the diameter. And then there's another point D, just random point D, I'm just going to put it there. 5 and 16. That is, let's quickly see, 5 and 16, that actually looks very familiar. I think B and C has the same x coordinate. Now maybe I shouldn't place it there. I'm going to place my D right above my B, like there. D is 5 and 16. Okay, show that DC is a tangent. Okay, this could be interesting. So you'll see, originally I thought, oh, I'm just going to put D there. But I want you to notice that this is 5 and 16, and this one was 5 and 1. So I do want you to notice that they are in line with each other. They want you to prove that this line is a tangent to the curve. So to prove that something is a tangent to the curve, the only way that I can think of now is to do a 90, to prove that that's a 90. And to prove that something's a 90, we use gradient. So if you want to use gradient, you can maybe work out the coordinates of C, then do gradient there and do gradient there. Let's first of all maybe get the coordinates of C. Remember, if it's a diameter and we're working with a radius and a radius, you can use reverse midpoint. Now, the normal midpoint formula, I know you're probably used to this one, x2 plus x1, or the other way around, doesn't matter, y2 plus y1. That gives you the midpoint of a certain two coordinates. But now, if you want to use reverse midpoint and you are given your midpoint, and you want to work out one of the outer 2 points, I would prefer you to break it up, almost like deconstruct this formula for me. So when we deconstruct a formula, you basically sub your midpoint in here, this is your answer, and then the 2 outer points there. So you can even call this x midpoint and x midpoint, if that makes sense. So your x midpoint in this case was B. So I'm going to sub in a 5. And your 2 outer points, we knew that A was -1, but we were unsure about the other one. All right. Then the other y midpoint was 1. And we knew that A's y was -2, but the other y was unknown. Okay, I hope so far deconstructed midpoint is making sense. Let's get x alone. Times by 10, times by 2 is 10. So I get my x as 11 and my y as 4. Okay, now I know I'm cheating a little bit, but I just want to see if this is correct before I move on too much. The coordinates of C is 11 and 4. Because it was quite critical to get the coordinates of C just for my plan. Remember, if I go up here, 11 and 4, why is it so critical to my plan? I need the gradient here, and I need the gradient there, and I want to prove that they are 90. I want to do it close to my sketch, so I think I'll just do it at the corner here. I want to do gradient. Sorry, I just forgot for a second what I'm doing. The gradient is y2 minus y1 over x2 minus x1. So if I do gradient of DC, I'm going to say 16 minus 4 over 5 minus 11. Please work that out. Go for it. Go for it. I get the gradient of CD is -2. Right. Then please do the same for the gradient of, let's do the gradient of AC or AB. I don't mind what you call it. Let's see what you get there. Gradient of AB. Use your coordinates nicely. You were given A, so I'm going to use -2. And then let's just use C. And I'm going to use -1, minus 11. Okay, if you work that out quickly, you should get 2.5. And then I want to remind you of this statement. If the M of DC times the M of AC equals -1, which is the case, I just checked, -2 times 1/2. If it does equal -1, it means they are perpendicular. And I think you need to make a statement. Let's just quickly have a quick look at the memo. They do want you to make a statement here. Yeah. So the fact that they are each other's reciprocal negatives, means they are perpendicular, so it is a tangent. You have to make that last little statement, otherwise you proved something but you didn't actually pull through and make the correct statement. Then C, the other tangent from D to the circle touches the circle at E. Find E. Now that's why I spent a little bit of time on my sketch, because I feel like, again, this is very important to look at. They say there's another tangent towards D, but it touches my tangent of my circle at E. Now it was very important to notice that D was in line with B, because if you are in line with each other, it means you are perfectly vertical. Have a look, that is perfectly vertical. So if I draw a line from the one side to the other side like this, it will be perfectly 90. I know that's not a perfect sketch, but you will see there's a theorem that says if you are 90, you will be halfway. So if you are 90, you will be halfway, which means you can use inspection even. They will lie on the same line. You will see that if this C is 4, the Y will also be 4 for E. And then if you want the X value, you can simply just add, like if I travel 6 units back from C to D, I need to travel another 6 units back to get from D to E. So I think I'm just going to say -1. I don't think there needs to be a method necessarily if your sketch was accurate. So let's see here. Yeah, there's no method. I love this. So if you just counted like I was counting, E is -1 and 4. That worked out nicely. The 2 tangents from D, and then you had your inspection to count. Okay, we're reaching the end of this. I hope you guys are not too tired yet. If you were in my class, I would have given you a break right about now, but you can just pause and then come back with a cup of coffee. Let's do 10. Number 10, calculus. Yes, please. The diagram shows part of a curve. So let me just write down my curve. First thing I will do is I will bring up that bracket and make it to the power -2, just to make it easier for whatever they're going to ask me next. So we've got a curve. We have a minimum point at M, which lies on the x-axis. Then they ask me a bunch of questions: derivative, second derivative, integration. Okay, we can do that. Oops, I showed you the memo. Wanted to show you what I've got. Yeah, that's my curve. Can you notice that I brought it up, made it to the power -2? Let me derive. I'm going to derive using shortcut chain rule. Shortcut chain rule works like this. You first derive the physical bracket. So I'm going to times to the front. That's how you derive. Times to the front, subtract 1, times by derivative of the inside. Yes, marks, say marks all over the show. -1. Because if you derive, you take your exponent, times to the front, subtract 1. So you'll just have 1. When I derive again, I just want to first clean this up a little bit. I'm going to just use reverse chain rule again. This is first derivative. Second derivative, the notation looks like this. If I derive this again, I'm going to use shortcut chain rule. Times to the front, subtract 1. Times by derivative of the inside. Constants fall away when you derive. Okay, so I'm fine with my deriving. I hope so are you. Don't lose marks here. Nice. And also they asked me to integrate. So I'm just going to quickly write down the instruction to integrate. Looks like this. So as soon as you integrate, please drop the instruction to integrate. This goes along with that to just please instructing, please integrate this middle part. So as soon as you do integrate, lose the instruction. I'm going to do reverse chain rule now. So reverse chain rule, you integrate the physical bracket. So you integrate the bracket, add 1 to the top, divide. And then you have to times by 1 over coefficient of x. You don't integrate the inside. It's not exactly the same as derivative. You're doing antiderivative. You're trying to reverse what you were doing there. So just to repeat, this is reverse chain rule. You add 1 to the top, divide, and then times by 1 over coefficient of x for the bracket. On the memo, I've seen 1 mark most of the time, or even 2 marks, 1 mark. So if you forget this, you lose a whole mark. And also, don't think that we're going to have -1 again. If you integrate x, you'll have x squared over 2. And don't forget plus b, because it doesn't have boundaries, so it's an indefinite integral. Yes. Let me just see if we're on the right track here. Maybe it will be interesting for you to also see. Yeah, you can drop it down or keep it with a negative exponent. I don't mind. And then they did put the plus c. I think we're pretty solid there. There's probably a reason why they're asking us all of this. This is 10a. Now 10b, find by calculation the x coordinate of m. Did you notice m is your minimum point? So just remember, if you're trying to find minimum or maximum, it means your gradient is 0 there. It's flat. It's a flat road. Gradient 0. And you must also remember that first derivative represents the gradient of a curve. So I'm going to be very selective in which one I choose from everything that I've done. For 10b, I'm going to choose u, first derivative. And I'm setting u equal to 0 because I know as soon as I know stationary points is first derivative equal to 0, I know I'm going to get a mark, a method mark straight away. You'll notice I did drop down my bracket because I feel it will be easier to solve it that way. I'm going to do a few tricks here to solve algebra. Bring my 1 over, because that wasn't my major trick. I'm trying to think what would be the easiest. Just times it that way. Okay, no, it's easier than I thought. I thought I was going to have to cross multiply or something. No, you just times that side, cube root both sides. Remember, cube root doesn't require plus minus. You can just cube root on your calculator, or hopefully you knew that. A cube root and a cube will cancel each other out, so you can drop the bracket. Let's just quickly solve this. This is quick. Okay, let's hope for a half. If I do go this quickly, I always feel like I might make a mistake. Do we get a half? Yes. Normally they would ask us to do full coordinates. Then you'll have to sub it back and get y, but I can even see that the y is not here. But just be careful, x coordinate is sometimes not enough. You might have to find the y coordinate. And then they want for question C, find the area of the shaded region bounded by the curve and the coordinate axis. They want this little piece. That's not difficult. If you want the area under a curve, I hope that you know this. Area under the curve, you integrate the curve and apply your boundaries. So I told you that there might be a reason for them asking you to integrate it. So I'm going to use my integrated version here. But this time I don't really need the C because I do have boundaries. Did you guys notice that it goes from 0 to M? So I'm just going to apply it here, if you don't mind. It's going to go from 0 to a half. What is it, a half? Yeah. Also, when you do have boundaries, as soon as you've integrated, you can just write it down. Just going to clean this up a little bit. So my integrated version, I know, is all of this. But if I clean it up a little bit, the 2's will cancel, the negatives will cancel. So I only have 3 minus 2x negative a half minus x squared over 2. No need for plus c. And then you've got your boundaries from 0 to a half. And then you just start subbing them in. Remember, your biggest boundary goes in first. So you'll do this. Sub in your half. I'm writing like microscopically small now. Minus, and then you sub in your smaller boundary. It will be 0. That will fall away if I sub in a 0. But just be careful. I don't think this bracket will necessarily give you 0. So maybe just do that. But I know the second part is just going to be 0. Okay, you can't see. I just made a statement that if that note goes in, this will still give me something, but this one will not. I feel like this is really enough to give you your method marks. So let me show you this button. That's going to change your life. If you are trying to integrate, let's say we were integrating from the beginning, you can use this button. And then you type in what it was originally your curve, which was 2 over bracket 3 minus 2 alpha x. Do you see where I find my pink x squared? Then minus alpha x. And then you put your boundaries in 0.5. And then you just press equals. It might take a while to think, but then you can just use that answer, 1 over 24, for your final answer. 1 over 24, but be careful, you can't really just you can't just use your calculator. You have to prove that you have your own brain. So you still have to do everything, even this last step where you sub the half in. That is also a method mark, I think 1 method mark. What I would have done, I would have typed this in manually if I have enough time and see if I get to the right answer. Okay, this is almost the end. How excited are you? 10B, find by calculation. We did that, we did the area. I think we've got 2 more. Let me just see, 11. One more long question. Okay, we can do this. We can do this. Okay, I'm just starting a new page. A curve has that equation. So we're working with 3 graphs. A curve has that equation. Y equals 3 cos 2x plus 2. Already what I'm noticing here. Amplitude change of 3. So it went 3 up, 3 down. So negative 3 and 3 would have been my maximum minimum. Period change of 2, which means it would take 180 degrees to make 1 wave, 2 waves in 360. And it moved 2 units up, and they want you to work in radians up to 180 degrees or pi radians. State the greatest and least values of y. Thank you for that question, but I'm first going to sketch the graph and then tell you. That's actually the easiest way. Because if you just had that question, I would already draw the sketch just to help me. So I think I'm going to start with question B. It's not a lot of marks though, hey? It's 2 marks. So don't stress out about sketching for Cambridge. It's not really a big feature. 3 cos, I did write that down. First things first, I would love to see some kind of Cartesian plane. You only have to go up to pi. If you're struggling with radians, obviously you can say just 180 degrees. Okay, something to notice with a normal cos graph, if you do like seeing the normal graph somewhere, this is my normal cos graph. Every 90 degrees, something happens, 90, 180, 270, 360. But that is if it's normal. The first things I'm noticing is it's not normal. It needs to make 2 waves in 360, which means actually your period will be 180. Which means that if I divide my 180 by 4, I know that every 45 degrees, something needs to happen. If you want to use 45 degrees, you're welcome, or you could use a quarter pi. But let me do it in degrees for you. I think it will be easier. So I'm just going to set my calculator to degrees again. If you wanted to see how I did that, I just went shift mode 3 degrees. And now I'm going to help you sketch it by using table method. So I'm going to say mode 7, which is table. And then I want you to type this guy in. 3 cos 2x, 3 cos 2 alpha x, and then close your bracket, plus 3. It's important to close your bracket there, or plus 2. Otherwise, the calculator thinks that you are busy with your angle still. Now it's going to ask you a few questions. We don't have to sketch another graph. Where do you want to start? I want to start at 0. Where do you want to end? Let's say 180 degrees. And your step is this one. The one that I said, every 45 degrees, something's going to happen. So make your step 45. Now, these are just coordinates. So 0 and 5 is my first coordinate. So I'm going to start at 0 and 5. And it's also good then to maybe break up your Cartesian plane into 45s. But remember, I know that the original had pies in. So rather do this maybe in pencil, and then rather write the radians in pen. So at 5, at 0, you start. Then at 45, you need to be at 2. 1, 2, 3, 4, 5. Just a rough estimation. So at 45, you need to be at 2. Then at 90, you need to be at -1. Don't have to be super accurate. Okay, and by the way, I'm reading like this. 0 and 5 and 45 and 2 and 90 and -1. Then you move down. 135 and 2. So 135 and 2 again. And then 180 and 5. So it needs to look like this. Bendy, bendy, nah? No straight lines. Curvy. And that is what they wanted, just that little dip. Some changes that did happen to the normal cos graph. Obviously, this is a full wave already in 180 degrees. The whole graph moved 2 up, so you lost your symmetry around the x-axis. And also the maximum minus the minimum is normally just 1 unit up and 1 unit down. But now it's like, from here, it's like 3 units up and 3 units down for symmetry. That's because of the amplitude change. And now I'm very ready to answer the question they had in the beginning. What is your greatest and least value? My greatest was 5, my least was -1. How easy was that? Let me just show you, y'all. Here, you could just read it off the graph. Check where you're getting your marks from though. A nice dip down needs to be a curve, not a straight line. And you need to make 1 complete cycle. Just for doing that, it's already a mark. And then your other mark will come from you knowing that you need to start at 5 and end at -1. Yes. Now this graph is quite important because we are going to use it for the next question. By considering a straight line, y is equal to kx. A straight line without a c value means you have to go through the origin. Okay. K is then your gradient, it looks like. State the number of solutions of when this straight line that I was just speaking about intersects your curve between 0 and pi. So if k is equal to -3, it will obviously go through here, through the origin, and it will be very, very, very steep, steeply negative. So if you want to draw like a little rough sketch of -3, you could have put in values if you really wanted to, but it boils down to looking like that. So you can clearly see I'm not intersecting my curve, so 0 solutions for point of intersection there. The next one, they ask you when k is equal to 1. So when k is equal to 1 means my gradient is 1. So it sort of looks like this. Remember, a 1 means it's a 45-degree inclination angle. So you'll only, it does look like you're only intersecting once, right? Let me just, yeah, they said 2. Which means that I might have to adjust my sketch a little bit. Because remember, this is now in pies, and this is in 1, 2, 3, 4, 5. So what I'm predicting is that this graph might look a little different. So I messed that one up a little bit. If you have a look at when k is equal to 1, for some reason I thought, obviously my scale is not the same for both axes. Here I'm counting 1, 2, 3, 4, 5, and here I'm counting like in quarter pies. So you have to, for this line, y is equal to x, you can't just assume it's going to run there with a 45-degree angle. You have to find a coordinate where x and y is equal. So what I found is half a pi, which is the same as 90 degrees, is 1,57. And here I also found like 1,5. So then it's going to go through the origin and then through that coordinate. So when you try and draw that, you know, if you ever miss a coordinate, just make it bigger. Not accurate, but it works. How many times do you intersect? They're not even interested in the sketch. They just ask how many times do you intersect? Then you will say you intersect twice. Because I just want to remind you of the question. They say, when k has a value of 1, how many solutions, say a number of solutions, and it's just 1 mark, 1 mark, 1 mark. So you don't have to even have a method. You could have even just put your hand there and seen, oh, okay, it's 2 solutions. The next question, the last one here, they say, what about when k equals 3? So then you need to have a very steep incline. You can use my original one that I drew for what was supposed to be y is equal to 1 or 1x. Or you could have coordinates. Make sure that your y coordinate is a value, and then your x coordinate is a value, and then you times your x by 3 to get your y value. But I'm predicting that it will probably look like this. It will be quite steep. And then you can just say, how many times do you intersect? How many solutions? 1 solution. Don't spend too much time on something that's 1 mark only. They even say here on the memo, 0 to 1. No method mark. All right, we're almost there. They give us the next page. They say the following things have happened. F of x, that's your normal graph. Now, g of x is your f graph, but you have times your x by 2. And you have taken your f of x, this whole f of x, and you've added 4 at the end. Now they say, explain to me what has happened to get from f to g. Okay, so I'm just gonna, I don't even care what f was originally, to be very honest. If they tell me my g of x is my f of x with your x times by 2 and your y plus by 4, I don't want you to actually look at the original, because that's just going to confuse you. Just look at this. This is theory. Remember, the transformation chapter is a new chapter, and it's just theory based. So the first thing I'm noticing is that your x was timed by 2. So that you need to go study. This is called a one-way stretch. And this is a scale factor of a half, or scale factor half. Because when you are in a bracket with your x, you have to always be the opposite of what you think. So for instance, if you had 2x equals a, what is actually going to happen to your a? You are going to divide by 2. So it's scale factor of a half for your x. If there was a 2 in front, it would be one-way stretch for the y. That's also something we actually need to say. One-way stretch, parallel x-axis, scale factor of a half. If there was a 2 in front here, you would say one-way stretch parallel to y-axis, scale factor, and then it would be proper 2. It's only the x that's funny. Okay. Another thing that I want you to see is this plus 4 happens after everything. So this is called a translation. You can either say 4 units up, or you can just say through this vector, 0, 4. Promise you, it's just studying. It's really just studying this theory chapter. Let me just see how they give the mark allocations there. Scale factor, half, parallel x-axis, yeah, 0 and 4. Excellent. Also, they want in the next one to explain to you what happened from F to H. Now, I'm just going to write down what H was. I don't even worry what F of X was. I just write down what has happened to my F. This is exactly what I was just speaking about, okay? If there's a 2 in front, guys, I've already said this. I hope you don't have short-term memory loss. You go one-way stretch. And then please say parallel y-axis. And then scale factor 2. Scale factor 2 for this one. And then the second part, I'm squeezing it in at the bottom here, it's going to be a translation. But now this time it doesn't happen after the angle. It actually happens inside the x or with the x. So I am just going to say again, translation. It will be with the x, but it will be either opposite again. So you'll have to say -1/2 pi, and no movement has happened for the y. So I think that vector works out nicely. Let me just make sure that I'm saying the right things here. Translation, check the negative, and then scale factor 2. And they said parallel to y-axis. And that is the paper. Fantastic. Guys, thank you for tuning in. It is a long journey. It is a long paper. Make sure that you understand every step. And I'm happy that you watched with me. You can subscribe for more videos.